Hey gang, I'm hoping to do a pretty quick tutorial here how to build a relative frequency histogram in Excel, as well as play around with the rules of the empirical rule within here. So let me get into it. I've got a data set called rainfall that's just got 60 values in it, and I'm going to highlight that row first of all, and I'm going to just title it rain. I've already done it, but if you go up in this box up here in the top left hand corner, you can type in the name rain or whatever you want and name that data set. So therefore, when we call back to it, it's there. So for example, if I wanted to find the minimum, I can use the minimum function and say min, open parenthesis, all right, and then rain. Type in rain, close parenthesis, and hit enter, and rain will appear. All right. If I want to find the max, the same thing. Hit the equals first, max, rain, close parentheses, boom. All right. Why you might want to find the min and max first is if you weren't given the class layout like I did for my frequency distribution that I want to set up. This will help you get an idea of how many bars that you might want to fit in your histogram. Since I went to 10 to 60, I went by tens and created this. All right. So let's say we wanted to find the frequencies for each one of these classes. So I need to find the frequency from 10 to 19.99. Excel has a counting function that will figure that out for us. We just have to know how to code it. So what we do is highlight the box in the first one and hit equals. And there's a function called count ifs instead of count if, count ifs. And what it takes is a criteria, which in our case is our data set. It's going to take rain. And then it's going to take, we're going to have to describe the lower boundary of our range, which is 10 in this case. So we do quote. We need to be greater than or equal to 10. So we're going to do greater than or equal to in quotes. And we're going to use the ampersand sign and 10. We're going to do another comma. I'm going to type rain in again. Comma. Quotes. We're going to be less than or equal to 19.99, so we're going to close off the less than or equal to with the end quote, and then do an and 19.99. Close that parenthesis and hit enter, and we should see 5 appear in that first box. We can now drag that formula and copy it into the remaining cells below, but we're going to have to adjust them. So for this first one, I need to change the 10 up here, right, to a 20. And the bottom one to a 29.99. And just need to change those really quickly for each one of them. Get outside the box, your cursor outside of this little box up here, and then hit enter, and it'll change. Not sure why it's giving me that. Inconsistent formula. Why is it inconsistent? Whatever, hopefully it'll work out for us. We'll find out. I'm going to do 30 to 39.99. No inconsistency there. Weird. All right. 40, 49. Enter 50, 59. Intra. And finally 60 and 69. Enter. There we go. That is our counts that fall in each one of those classes. Now we need the relative frequencies for them so we can make our histogram. So get the relative frequencies, type in equals, highlight the very first frequency cell, and do divided by 60. I told you guys there was 60 in there already, but that'll give us the relative frequency for that. And yours may not automatically come up with 2 decimals if you didn't format your cells, but you can change the number of decimals back and forth by adding or subtracting using these 2 little buttons up here. But two's enough. If you didn't know how many data values were in the data set that we were given, you can highlight the frequency column and just do a quick count by doing auto sum, and it'll tell you the grand total was 60. All right, so now we've got enough to make our histogram. So highlight the classes, all right, hold down whatever you need to do to jump. In my case, it's Command on a Mac. jump over here, hold down Shift, and then go down to the bottom and highlight that list, and then go up to the top and do Insert. And go to Recommended Charts and pick the very first one, and you've got your chart here you can play with. I recommend doing a few things first. There's an option up here that says Add Chart Element. I would go through here and add axes titles for the primary and the secondary axis, or the primary vertical, primary horizontal as they call it. All right. As well as go to the Data Labels option, and you can put your relative frequency values above each bar by going down here and choosing Outside End. Boom, it pops up there. And you can change your titles as we go here. It doesn't look like a histogram right now because the bars have a big gap between each set. To change that, double click or right click and choose Format Chart Area. Format Chart Area is down here. But if you double click on the graph itself somewhere, this will usually open up on the side in Excel. And click on the bars within the graph and go over here to where the bars are at in Format Data Series. And you want to alter the gap width. So you can slide it if you want. I'm just going to highlight this and put in 3% in tab, and boom, it looks a lot better already. I recommended changing the chart title to, like in this case, Rainfall Histogram is a good generic title, but whatever you're trying to do, label your graphs correctly. This side should say relative frequency. All right. And the bottom title here is usually always a representative of what the data set is. In this case, it's rainfall. We'll call it rainfall. If this was in inches, we'd put in there inches or whatever. And then maybe hit enter and then put n equals 60 to show your audience, not capital N, but little n equals 60 to show your audience that you have how many data values were in the set. All right, and there you go. You can also play around with this and change the colors and all that stuff. Highlight this and go to fill real quick, and I kind of like other colors, so we're going to choose that. That looks a little bit nicer. All right, so anyway, have fun with that. Now let's play around with the empirical rule. Remember, this is the 68% is between one standard deviation unit away from the mean in both directions. Between 2 standard deviations away, it's 95% of the data falls between it. 3, that's what this K, 1, 2, and 3 represent here. But before we can find these lower and upper boundaries for our intervals, we first need to calculate the mean and the standard deviation. We'll do the variance too. So the sample mean is, we'll do equals, and it's average. It's just average in Excel. So average, and just do rain, enter. The sample variance is called var.s. If I can get my dot in there, s, and rain. Oh, I need to put an equals in there first. Equals vars, or var.s. There we go. Rain. And the sample standard deviation is STDEV. I need to put equals in there first. STDEV dot S for sample. If you want population, you change the S to a P. And this is rain. And there we go. Again, mine are automatically set to give me 2 decimals, but you can always alter that with these little functions up here. So now I'm going to use that to find my lower and upper boundary. So to find the lower boundary for this I'm going to take hit equals and take the sample mean. I'm going to subtract from that this K value here times the sample standard deviation. And up here, to kind of help out, I'm going to put a money symbol in between the K's and the numbers. That way that the formula will transition properly when I drag it. All right, and get the cursor to the end, hit enter, Now we should be able to grab that sucker and take it and drag it down, and there we go. There are lower boundaries for each of our intervals 1, 2, and 3 standard deviations away from the mean, below the mean. To get the upper, we're going to hit equals. Pick the sample mean plus this time is the only difference, and we're going to do time again the 1 or K7 times times the standard deviation. And again, I'm going to put the money symbol in between the K and the 1 and the K and the 3. This just helps if your mean and standard deviation move somewhere else on your sheet, it keeps track of where it was at, or will follow it where it's at apparently. So again, get the cursor to the end, hit enter, and we're going to take that thing and drag and drop it down. Boom, we got our upper bounds. So now we need to use our upper and lower bounds that we have here to find the frequency. All right. So we use the countifs command again. We're going to use these as our boundaries. So use equals count ifs. The range is still a range because we're still hunting through the data set. And we're going to do like we did before. Quotes, we need to be greater than or equal to that lower bound. All right, in quotes, and we'll do and. We'll do K7, comma, rain, comma, quote, less than or equal to, in quote, and ampersand again, and this time L7, so next to that column up, the upper is in M7 in this case, 7, close parenthesis, and hit enter. It tells me there's 49 data values. I'm going to take that formula and drag it down. And there we go. It actually did it correctly. You want to double check it sometimes that it didn't alter anything. L8, M8, good. All right. So now we do the relative frequency equals the first freak divided by 60 because that was the size of our sample still. Enter and then drag and drop that. What you'll notice here is I've left the empirical rule values from what we learned in lecture here. You can compare across these. The 2 standard deviation units apart, the 92% is not far off from 95%. So there's almost 95% of the data between the first 2 standard deviations. That's not bad. But a lot of the data is in the first standard, within 1 standard deviation from the mean, which can be a little bit weird and wonky. I don't think this data set, it's very approximately normal, but it's not what I would call entirely a normal data set. Okay, it doesn't look terrible. It's not the worst thing I've ever seen, but I would go, when you're not sure about the way the percentages match up, always go back to look at the graph, because the graph's kind of a giveaway, kind of a dead giveaway. Most of the data does indeed lie in the middle, and all of it lies within 3 standard deviation units. That's not quite uncommon when we have a small data set like this. But anyway, when you're writing up an analysis for something like this, or you're trying to decide what you think about the empirical rule or how does it hold up, make a comment like I just did, generalized comments. The data, there's a lot of data, more data, it falls in between the first standard deviation. We're really close to following the empirical rule within 2 standard deviations, and everything fits between 3. So 2 and 3 are good, but that everything being kind of bound up in the middle might be kind of questionable. All right, that would take for us going into the data set a little bit further. But anyway, that's it for now. Hope this helps, guys.